A lot of parents have actually been asking me this. Lately, I've been facing this question quite a bit. Many parents ask me, "Teacher, what's the actual difference between math and seeing skill?" Some parents even say, in missing skill, what exactly is the math part about? Actually, this is a question that parents have been asking me for a long time. What's the difference between math and thinking skill? What's really different about them? So today, I'd like to use a question from the Australian National Olympiad as an example. I'll use a question from the selection test to explain this to everyone. So, what exactly are the differences in what thinking skill and maths are testing? Alright, let's take a look at this question together today. This question is from the 2017 Australia Intermediate. It's one of the multiple choice questions from the Maths Olympiad, a selection question. So, it says, there is a triangle like this, a triangle that could be any shape. It could be an acute triangle, a right-angled triangle, or even an obtuse triangle. They didn't specify anything about it. But it just explicitly states that they meticulously drew lines to divide it into 4 perfectly equal sections. So, I carefully divided this particular triangle. Along one of its prominent sides, I precisely drew 3 parallel lines. This splits it into 4 sections, Then, it tells me that the second largest section, which is the one in the second row from the bottom on the right, is 225. So what does that mean? Actually, 225 centimeters squared. The question is asking for the whole area of triangle ABC, right? Now, let's look at this problem. If we look at it from the perspective of messy metrics. Right, then what we really need to carefully consider first and foremost is this fundamental concept. And when we meticulously calculate the area of any given triangle, we all inherently know and understand that the area of a triangle is precisely equal to 1/2 of the base multiplied by its corresponding height. That's the basic knowledge we currently possess, right? Break time equals 0.5s/, and then, if we use this knowledge and apply it to this particular question, what we can clearly find is that even if we don't precisely know exactly what the base truly is, we know that these sections are indeed equal to each other. Right, if they are equal to each other from a mathematical point of view, what I'm thinking is, because what I'm focusing on is finding the base, I'm finding the height, aren't I? So then, according to this formula, from a mathematical perspective, what I'm thinking is that I can look at this triangle, into this shape. Right, because in this way, we'll know that all the triangles have the same base, this base. If, say, there's another triangle and its base is twice as long. Right, the height for this triangle and the height for this triangle is also doubled. Right, no matter what the height is, but the height is definitely doubled because they are all equal, right? So from this point of view, I'm thinking about if the smallest triangle, its area is 1. Then the larger one, which is the ones here. Right, the ones here, because the base is doubled and the height is doubled, so the area will be 4 times as much. Since this is 1, then this must be. So this trapezium, if we look at the trapezium, this must be 3, right? Because we know in total this triangle is 4 or 1, so this total triangle is 4 then. The small area is 1, then the trapezium, it will be 3, so altogether it's 4 sections. Isn't it? So then we are going to be using the second bit of knowledge. This question is about the ratio. Right, the ratio of the smallest triangle and this trapezium will be 1, 2, 3, right? That's the ratio between these two shapes. Right, if we can apply the same concept to the larger triangle, then what we'll find is, if this is 1, right, then this, the second largest triangle, which is the red one I just marked. This base is 3 times the base, the height is 3 times the height, so altogether this one should be 9, right? If this is 1, then the total big right triangle should be 9. So since now we know this is 1, this is 3, so the second trapezium there will be 5. Yeah, because this is the ratio, so we can get, since the ratio between the smallest one and this red triangle is 1 to 9, and then the ratio must be 1, 3, 5, which is the smallest, the second trapezium, and the trapezium. Right, it's 1, 3, 5, and we can use the same concept for the biggest one, this time the biggest one here. Right? The base comes to 4b, the height is going to be 4h, so altogether it should be 16, right? 16, since we've already got 9 here, so the largest trapezium should be 7. So now we know the ratio from the smallest triangle to the second trapezium, third, second trapezium, and the last trapezium should be 1, 3, 5, and 7. That's the ratio of their areas, isn't it? Now we know for the 5 section, this is 250. Now they're asking us for the total area, so basically, we're using 250 divided by 5, and then it's times 16, right? Because the total ratio is 16. So now we only need to do a very, very simple calculation, then we'll know the answer will be 720. Right, that's how we solve it from a mathematical point of view, because we know the area formula, we know the concept of ratios, and with these two basic pieces of knowledge, I can solve the problem in this question, right? Of course, you can get this question right, but in terms of thinking skills, what are we thinking about with this question? Right, let me just erase everything. Then we'll go back to the very beginning. So, in terms of thinking skills, right, when we look at this question, actually, we are not just limited by the knowledge. What we are more interested in is, since the question you're giving me is about an irregular shape, which you're telling me is that this trapezium is in a ratio of 2 to 5. Right, in thinking skills, we have a very common concept called unit area. Unit area is very useful when we're dealing with irregular shapes. The basic concept is, can we find the unit area, which I can apply to the whole area to break it down into small, regular areas or shapes, right, that can cover the entire big shape. That's the basic concept of unit area, right? Since now we know this trapezium is 225. Now, what I am truly thinking about is, can I precisely cut this particular triangle ABC into much smaller, identical geometric shapes that can completely cover the entire area of the original triangle of ABC? Can I do that then? That's how we use thinking skills, right? So after we think about it this way, what we can easily do is cut them by using the same parallelogram, with parallel lines. Right, if I cut it this way, you'll find that actually each of these small triangles will be the unit area of the whole triangle, of the whole shape. Right, that's it. I just divided them into, in total it's 16 small triangles, and they're all identical. This is a very common strategy we're using here. Now, since we know 1, 2, 3, 4, 5, I know 5 of these small triangles equals 225, right? And now I want to know the total, which is 16, because this is 1, this is 3, this is 5, this is 7, so in total I've got 16, so also the answer is 720, but the whole process is going to be much easier, and the knowledge you're using is just very basic division and multiplication. Okay, so this is one question that I'm solving both using a mathematical method and by using thinking skills, okay. So this question is a really good example to explain to everyone that, in maths, what the exam is really testing is your understanding of mathematical knowledge. In other words, if you don't have this kind of mathematical knowledge, say, if a child doesn't know how to calculate this, the area of a triangle, then basically, you pretty much won't be able to get this question right. At the same time, in this, on the basis of understanding or mastering this mathematical foundation, it might test some practical applications, but mainly what it's testing is still your understanding of this mathematical knowledge, whether you know it, and whether you can use it proficiently. But when it comes to thinking skills, you'll find that it's actually not really testing how strong your mathematical knowledge is. It's more about assessing your way of looking at things, your approach to viewing things properly, in other words, how you go about understanding a problem. Of course, I could just see this as a simple area problem, but more importantly, I could actually understand this problem as something else. I could see it as a concept we call a breaking the whole into parts or a combining parts into a whole, and that is, I turn it into something like that. The unit area I can apply, then I can apply it to the larger one, right? This is the concept of moving from the local to the whole. This method, in fact, is just one application in this particular problem. Actually, this way of thinking is something we use, consciously or unconsciously, in solving many problems. So, in our teaching process, the most important thing is to distill these ideas out. We need to make sure the kids understand, to let them know the method they're using. Because only when they clearly realize, okay, this is actually a method I'm applying, will they consciously use it again when they encounter similar problems in the future. At the same time, this will further strengthen their understanding of this approach. They'll recognize, look, I've come across this method again, and I'm using it. This is a key point we emphasize when teaching thinking skills, to distill these methods and present them in different ways. Tell the kids that this method can actually help them solve many problems in a really elegant way. But you'll notice, once you've found this method, the knowledge you need to use is actually very, very simple, right? Unlike the first approach. You also need to know base times, height, and then you have to think about when the base is doubled, when the height is doubled, and then the area is going to be 4 times as much. Right. But with this kind of thinking skill, what are you actually using? It's just a simple division and multiplication problem. I believe even year 1 or year 2 kids could do this, right? Actually, most of the time, the key is right here. I hope that by explaining it this way, I can give everyone a bit of an idea about the differences in what thinking skill maths is actually testing. So here, I'll give everyone another question. There's a problem like this. It says the area of ABC, the big one, is 100. Now I'm asking you, what's the area of the small one? Okay, I hope this question can help the kids get even more familiar with the method we just talked about. Okay, so if anyone has an answer, feel free to let me know in the comments section, and I'm also happy to discuss it with everyone there. Alright, that's it for today. Thank you, everyone.